Hello, and welcome to the first video of week 5/week 1 of stats. What I want to do right now is go through some vocabulary for some statistics in this first video. So we're going to start here. So the first thing we need to talk about is that statistics is really broken down into two categories: descriptive statistics and inferential statistics. This week we're going to focus on descriptive. Descriptive stats, before I read off the slide, are really the statistics that you can glean from the data perfectly. What does the data say about the population that you're looking at? Now, I use that word population because if I'm doing descriptive stats, it means I can only make judgments about the people I collected the statistics from. If that population that the data came from is actually a subset of a larger population, then we call it a sample, and we use that sample to hypothesize about the whole group at large, the larger population. That would be when we do inferential statistics. So descriptive is collect data, report on that data only. Inferential stats is when you collect data as an option toward talking about a larger group as a whole. So in descriptive stats, we collect data here. We state some observations about that data. We present it numerically or visually. We summarize it, and we'll talk about all the ways in which we can summarize it later. Inferential stats is when we collect sample data. We state observations on that sample, but then we say, hey, because the sample did this, I think the larger population as a whole is going to do something similar. And then we make some hypotheses as we summarize that data. Now, population versus a sample. I've already talked about this a little bit, but the population is the group of all items of interest. Sometimes I can collect all the items of interest. Other times I can only collect some of that population, and we call that a sample. It's a subgroup of the population. Samples are really important because there are many times where getting the population as a whole is impossible. And if not impossible, it's just impractical. When you talk about this from a business sense, we often look at samples because it's cheaper to collect a sample than it is to find a survey for the entire population. Other times it's impossible. If you're the FDA and you're trying to approve a new drug, let's say a new vaccine that's coming out, you can only look at so many syringes of the vaccines that go out the door. If you looked at all of them, you wouldn't have any vaccine left. If you had to be the FDA again and think about a pill, if you were going to create some new aspirin, the way that they figure out if that aspirin is appropriate is by crushing it up and looking at the active versus inactive ingredients. If you crushed up every aspirin, you wouldn't have any aspirin left. So then you say, okay, let's just get a sample. I'm only going to crush up 1,000 or 2,000 or 10,000 aspirin to make sure that this is okay before it goes out the door. Now, since we often talk about samples, there are lots of different types of samples that you can collect. There's probability samples, which are the best kind, where everybody has an equal chance of being selected. And then there's non-probability samples, where unfortunately not everybody has an equal chance of being selected. Now, probability samples, a lot of this is you being a good consumer of statistics. Realistically, you guys are not going to collect random samples. It's just not going to happen. But we try to when we can. So there's a couple different types of probability samples. There's the simple random sample, where you use the idea to draw somebody on pure chance. This is very difficult to do. That would be something where, let's say, everybody who walks out the door, I flip a coin and see heads, I ask them a question, tails, I don't. Systematic sampling is saying, okay, I can't flip a coin every time somebody walks out the door. I'm going to ask every fifth person who leaves a movie theater on a given day, hey, can I ask you, did you like that movie? Hey, can I ask you, did you like that movie? But you do it one every 5 times. Stratified sampling is when things are segmented into groups and you take a sample from each group so that your samples are proportional to the population. Okay. An idea of stratified sampling, sometimes called cluster sampling, I'm going to go back to the movie theater idea, is if you say, you know what, I'm going to walk into a movie theater and see if people like the theater, but I'm only going to go into, theater 1, theater 8, and theater 14. They're already clumped, and so you just ask specific clumps. A non-probability sample is one where you can't get everybody. Not everybody has an equal chance of being selected. Usually this means you're doing a judgment or a convenience sample. A judgment sample is when you pick a sample based on the fact that you think they are a good representation of the population. You know what, there's about 50% men, 50% women. I'm going to make sure I get 50% men and 50% women, but just ask specific ones. Not a good idea if you can avoid it. Convenience sample is, let's be honest, how most samples are actually taken in the real world. That's when you have like a voluntary response, or, hey, I want to know how businesses do this, so I'm going to just ask people within my business because they're the people I have access to. Now, what can you do with those samples once you collect them? Because probability samples are where every person has an equal chance of being selected, or every item has an equal chance of being selected, you can do inferential stats on those relatively easily. When you do a non-probability sample, a judgment sample, a voluntary response sample, you really shouldn't do inferential stats on those. That said, we're going to do it anyway, and plenty of people do it anyway. But in the world of statistics, we try to avoid doing that if possible. But what I've said to you now, and what I will say to you over and over again, is as long as you inform the reader, then you can kind of play it a little fast and loose with what you're willing to try and not try. So if I'm going to do some inferential stats on a sample that was a non-probability sample, I would have to tell the reader, this was a voluntary response. I let people decide whether they were going to answer me or not answer me. Or this was a call-in sample. It was a radio show, and if people called in, that's how I got their results. So as long as you give the reader the information where the data came from, you're letting the reader decide if it's something that they decide to believe or not believe. So the types of variables or data points that we can collect can either be numerical answers or word answers. Numerical answers would be quantitative. Word type answers are categorical or qualitative. Now, I boiled that down to very specific, very broad layman's terms at first by saying numbers versus words. It doesn't have to be numbers and words. It can be other things as well, but whatever you collect is going to be assigned as either a categorical or a numerical data point. Categorical questions, categorical variables would be things that cannot, that don't represent numerical values for the most part. Hair color, gender, military rank, favorite color, other things that are categorical that have a number might be area code or zip code, because sometimes numbers are really representatives of of something else. So anything that is about a category or quality of something, did you like this or not like this? That's a categorical variable. Categorical variables actually have two subgroups, nominal and ordinal. Nominal categorical variables cannot be ordered, gender and hair color. But then other types of qualities might have some kind of a ranking to them, such as your year in school, freshman, sophomore, junior, senior, or a military rank. All categorical data is also called discrete because it's one thing. What's your favorite color? Red. Okay. When we get a numerical data, we can have either discrete or continuous data. Discrete, layman's terms, is more like a whole number. And then, pardon me, continuous is when you allow there to be decimal values, 3.4, 3.08, things like that. Numerical data is exactly what it sounds like. It's numbers. How many children do you have? How many years did you go to school? How many TVs are in your house? It can also be things like year or temperature, or how thick is this metal plate that's about to go into a machine? What score did you get on your last test? Those are all numerical values. Now, numerical values also have two subheaders, and honestly, in all of my years of teaching statistics, I've never really had to differentiate between them, but to make you a good consumer of statistics, I want to give you the vocab. Interval data is when 0 is not the bottom of the data. And the only two great examples I can give you for that are year and temperature. Ratio, on the other hand, has a true 0. Ratio numbers and is when 0 is the absence of the thing. How many children do you have? 0. That means the absence of children. How old are you? 0. That means really the absence of age. You haven't really been born yet. Salary, 0. You're not making any money, like, 20 million Americans right now during this awful time that we're living through. Qualitative data, like I said, can be, that should say quantitative data. Glad I'm going through this with you, because quantitative can be categorized as discrete or continuous. A continuous piece of data would be like weight or height. Discrete would be birth or SAT score, when you kind of have chunks between the numbers. All right. So what does this mean for you? Let's talk about surveys for a second. If I have a survey question, or specifically here a survey statement, I'm just finding all kinds of typos and I'm making you sit through them, and I apologize. If I have a survey statement that says something like, my boss supports my education, yes or no, that would be a qualitative response. Either they do or they don't. That's not a number. If I change that survey statement to, my boss supports my education, strongly agree, neutral, disagree, or strongly disagree, that's still a qualitative statement. It's the level to which your boss agrees. But now that level can be ordered, so that would be qualitative and ordinal. And then last but not least, responds with a number 0 through 7. Now we're taking a qualitative response and assigning it a quantitative value from 0 to 7. So I have some answers on the other slide here, but there's an argument that number 3, even though it's numerical data, represents a qualitative or a categorical value. Okay, so sometimes numbers really mean words, and we'll get to that later. Another example here, a quality control auditor has visited a shop that makes parts for a blood analyzer. He's interested to see whether the splitch plate within the analyzer fits specifications to within acceptable range. They've got 10,000 parts and they're in boxes of 1,000. The auditor chooses 30 parts from each box and uses his caliper to measure the thickness of each. Basically, what are we doing here? So this is a perfect example of sampling data to collect information. So the factory's got 10,000 parts and they're in boxes of 1,000 each. The auditor's not going to measure all 10,000, so he chooses 30 parts from each box. So what type of sampling is that? Well, he's sampling using cluster sampling or stratified sampling because it's already chunked. What's the population being observed? Well, he's sampling the 10,000. So the population being observed is the 10,000 parts. What variable is being studied? Well, he's pulling it out of the box and he's measuring the thickness. And so with that thickness gets our variable. Our variable is going to be the numerical thickness of each plate. Now, since it's numerical, I'm going to qualify it as either interval or ratio. This is ratio because 0 is the absence of thickness. There is a true 0. And it would be continuous because 1/10 of an inch and 1/20 of an inch are different values. So I'm looking at different types of decimals and fractions in there. Okay, so we are at the comic part of the lesson. So I am going to stop here and make this video number 1. So take a break and come back later for more statistics.